Everyone, so welcome to this video. So in this video we're going to be talking about one of the popular sorting algorithm, which is insertion sort algorithm. So basically we'll be discussing what is insertion sort algorithm, and then we're going to be understanding it by taking an example, by going through an example, and then we're going to convert our algorithm into a computer program written in Java and test it. So this is what we're gonna be checking out in this video. Yeah. So first, what is insertion slot? So insertion slot algorithm is, as name suggests, it is an algorithm to basically sort an array or a list in a descending order and ascending order. So basically the idea of assertion sort algorithms or logic is to build a sorting array. So it's a build a sorted array by taking one element at a time from the given input list on array. So the point is that suppose if we take this example, so insertion sort will be starting the algorithm from the second element of the list on array. So for simplicity, I'll be telling it as list rather than saying list on array. So we'll be in insertion sort algorithm. We'll be starting from the second element of the list. Then when we are in the second element, we'll be doing the sorting for first two elements, and then we'll be moving to third element. We'll be doing the sorting for third element, and then we'll be continuing this. So if you are in the ith element, so all the elements till ith position are sorted, and all the elements after ith position are unsorted. So basically we're going to be running from second element all the way to last element, such that when we are in the last element, all the elements which are on the left are sorted along with the last element as well. So this is the idea of insertion sort, is to sort an array iteration by iteration by adding each element up to the by taking each element into account for in every iteration. We do the sorting again and again. So basically, this is not a very efficient algorithm when we particularly talk for larger input sizes. When we compare it to quick sort or much sort or even heap sort as well. So and also this insertion sort algorithm is considered as in-place sorting algorithms, because in this sorting algorithms we are not creating a new array or a list to store the sorted elements, right? You are using the same list to store the sorted elements, and also to have the unsorted as well when we are processing it. So the idea is that when we are in the ith position, all the elements left to the ith position are sorted on all the elements right to the ith position are unsorted, and we'll be going all the way from second element to the last element, such that when we are in the last element all the elements are sorted. So this is the basic idea of insertion sort. So to implement this logic, basically, popularly, mainly, we have two main logics. We'll be discussing both. So the difference between both logics are not much. So even the time complexity or space complexity is same. Even the logic is not much difference, but there is slight difference. But however, we will be discussing about two logics in this video. Yeah, so first we'll start with the first one. So in the first one, as we mentioned, the sorting is done by comparing the element with its precedence and do the swapping if needed. So if we go into detail, so the idea is that suppose if we take this as an example, so whenever we go to the new iteration, we'll be comparing the element pointed out by the loop variable. So this is the new element with the element preceding in it. So basically we'll be comparing the new element with the elements preceding this new elements, so which is a sorted list, and doing the sorting. So how we do the sorting is gonna be that is what we're gonna discuss. So how do we do the sorting? So first, we'll be comparing the element, new element, with the element preceding by it. So if the preceding element, value of the preceding element is greater than the new element, we'll do the swapping. We'll swap the preceding element to the ith position, and we'll swap the new element to the preceding position. And then we again do the comparing between the new element and the preceding element. So if preceding element value is greater than the new element, we'll again do the swapping. Otherwise, we'll be stopping here and we'll be going to the next iteration. So this is how it gonna be works. It gonna be working. So whenever we go to a new iteration, we'll be comparing the new element with its preceding element, and we'll be doing continuing this swap until we find a place where such that the preceding element value is not greater than the new element value. So when that is the scenario, we'll stop over here and go to the next element in the list. So this is the basic idea of this logic. So just we're gonna go through this example to have a better understanding. So first I have a list of this 53, 12, 35, 21, 15, and 15. So as I said, we'll be starting from the second element. So we'll be comparing the new element 12 with 53. So since preceding element is greater than the new element, we'll do the swapping. Yeah. As we have done the swapping, this is our new array, new array or new list. So since as we after doing the swapping, there is no preceding element before the new element, right? So that's why we're gonna be incrementing to the next element. Now the new element is 35. So now we're gonna be comparing 35 with the preceding element. So the preceding element is greater. 35 is 53 is greater than 35. So we're gonna be doing swapping. So now the element will be 12, 35, and 53. So since now we are in 12, 35, and 53, so the preceding element to the 35, 35 is the new element, is 12. So 12 is not greater than 35, right? So we're going to be stopping here and we're going to be incrementing to the next element. The next element is 21. So again, we do the comparison between new element and preceding element. We do the swapping. So now 21 came to here and 53 came to here. So now we're gonna be again comparing the new element with the preceding element. So again, preceding element is greater than 0. So we're gonna be sorry, not preceding element is greater than new element. So we're gonna be swapping preceding element with new element. Yeah. So after the swapping is done, it's 12, 21, and 35. So when it is 12, 21, and 35, the preceding element 12 is not greater than 21. So we're going to be stopping and we're going to be going to the next element, which is 59. So when we are in the 59, we can see that the preceding element is not greater than the new element. So no swap is required. So you're going to be incrementing to the next element. So the next element is the last element here. So here, so the preceding element is greater than the new element. So we're going to be swapping. So now 15 comes before and 59 goes after. Again, we're going to compare the new element with the preceding element. Again, preceding element is greater. We're going to swap it. Again, we're going to be comparing new element with its preceding element, which is 35 and 15. Again, preceding element is greater. We go do the swapping. Again, we continue it. Preceding element here as well is greater than the new element, which is 15. So again, we do the swapping. So now we compare the preceding element, which is 12, with the new element 15. So now preceding element is not greater than new element. So we don't do the swapping. We stop it here, and as until as we have reached the endpoint of array, we're gonna be starting the algorithm. So now we can see that the algorithm has been sorted: 12, 15, 21, 35, 53, and 659. So this is how this algorithm works. So here the idea of I variable is to keep a notation. It's to keep a note that the note about the position till which the array has been sorted. So if I equal to 3, it means that all the elements till 3 are sorted. So when we are in the new when we go to the new iteration, so what do it basically do is we're gonna be creating a new variable. Suppose if we take here, so we are in like index 1 0 1 2 3, so here we are in index 3, right? So now we're gonna be creating a new variable j, which is 2. So 2 is nothing but I minus 1. So we're gonna create a variable called j, which is I minus 1, and we're gonna be starting a loop all the way from j minus 1 to I, j minus 1 to first element, which is zeroth index. So why we are doing this is we have to compare the first, when we are in the j equal to I minus 1, we're going to be comparing the newth element with the element preceding it, right? So we're going to be comparing j minus 1th element with jth element, and after that if there is any swap needed, we're going to be decrementing it. We're going to be pointing from j minus 1 to j minus 2, and as we have done the swapping, we're going to be comparing j minus 2 with the j minus 1, and then we're going to be going on this loop, going to be continuing until we reach a scenario where preceding element is not greater than the new element. So this is how it works. Whenever we reach a new iteration, we're going to be creating a new variable, which is j, which starts from I minus 1 and will go to all the way to 0. So inside this loop, we'll do the comparison of jth with the jth position, and if needed, we do the swapping and also decrementing j. So we'll be continuing this until we find a correct place for the new element. So after inner loop is done, we'll go to the next outer loop. So here we're gonna be having two loops. So whenever for every I, we're gonna be starting a loop from j minus 1 to I minus 1, and the outer loop is for I. So after inner loop is done, we're gonna be going to the next element of the list. So since we have understood this logic with an example, so the logic is basically comparing the element with its precedence and doing the swapping if needed. So we're gonna be this is the computer program for this algorithm written, which is written in Java. So here I have a method called insertion sort. So this method takes an array. So over here I have created an variable, so which is gonna start from the second element. Second element is the first index with 1. So and it gonna be going all the way to n minus 1th element, which is the last element of the array. So here n is the length of this array. So inside this, for every I, we're gonna be creating a new variable called sorry, inside for every j, we're gonna be creating a new variable called I. So we're gonna be starting I from j minus 1 and all the way go to the first element. So inside this inner loop, we're going to be comparing element which is at ith position with its precedence. So suppose if precedence is greater than, suppose here we are checking, right, array ith element if is it greater than I plus 1 position, right? So if precedence is greater, we do the swapping, or else we're gonna break the inner loop and we're gonna be going to the next element in the outer loop. So this is what we have discussed. Whenever we are in any iteration, suppose here we are saying we are at 53, right? We're gonna be creating a new variable j minus 1, which gonna be starting from which is going to be starting from I minus 1 all the way go to 0, and do the necessary swapping if needed by comparing the element with its precedence. So by comparing the new element with its precedence and doing the swapping if needed. So this is what the computer program which we have just discussed. So we're going to be having two loops. One is for j, which is for traversing all the way from a second element to the last element, and other element which is going to be it's a loop to traverse from j minus 1 position all the way to first element to compare the new element with its precedence, and we do the swapping if needed. So this is how the computer program works. So here we can do one change over here, so you can improve one position. So here inner loop we will only need whenever the precedence is greater, right? So instead of writing else and doing a break, we can include this condition in the while loop itself. So if we gonna include this condition in the while loop, we can remove this else and break. Yeah, so this is how the computer program for the first approach works. The, the approach is to do the sorting by comparing the nth element with its precedence and doing a swapping if needed. Yeah, so now we're gonna be checking out the second approach. So even in first approach or second approach, the main thing is we're gonna be doing the sorting of the list part by part. Suppose if you are in the second element, all the elements left to the second element are sorted. If you are in the ith position, all the elements left to the ith position are sorted. So here even in the second approach as well, it's the same. The only difference between first element and second element is, as I said, right, when you are in the ith element, all the elements on left to ith should be sorted. So how do we do that sorting is different in first approach and the second approach. In first approach, we are comparing the new element with its precedence and doing the swapping if needed until we find a place where precedence value is less than the new element value. So now let us check the idea of the second approach. So in this second approach, the basically the idea is that whenever we go to a new iteration, so we're gonna be storing the value of the variable, loop variable, so in a variable called key. So suppose if you take this example, so here I mean we are starting from the second element of the list, right? So here I'm going to storing this 12 in a variable called key. So then we're going to be comparing the element before it with the key. So if the element before it is greater than the key, we're gonna be shifting the jth position element. So j is like, suppose we are in ith position, we're gonna be creating a new element called j. J is like j starts from I minus 1. So we compare jth position with the key. So if jth position element is greater than the key, we will shift jth position to j plus 1. So and then we're going to be decrementing j to next one. So and then we're going to be again comparing jth position value to the key, and again if value at jth position is greater than a key, we're going to be shifting j to j plus 1. So the basically in a nutshell, the idea is that whenever for every iteration we'll be reaching a new element, right? So idea is to shift all the values left to ith variable. So ith the variable I, so which are greater than the value which is present at the ith position. So suppose here you can say I am pointed out 35. So the logic is to shift all the variables which is left to this variable I, which are greater than 35. So we'll be shifting all the values which are greater than to right side, so that we can find a place for our key. So the key is value pointed by this I variable. So once we find a place, we're gonna be inserting this key to that place. So basically the logic in this approach is to shift all the variables in the left side of the array which are greater than the variable pointed by which of the variable pointed by I variable, and to find the appropriate place for the value present pointed out by I variable in the left hand side of the array, which is a sorted array part of the given input. Yeah, so this is the idea. So let us go through the example here to get a better understanding. So here I have this array first in the beginning. I have 53, 12, 35, 21, 59, and 15. Yeah, so as I said, we're gonna be starting the insertion sort algorithm. Will start from second element. We'll go all the way to the last element. So here I am currently I'm in the second element. This is pointed by this I variable. So now I'm gonna be comparing. Now when I'm in this position which is pointed by I variable, I'm gonna be creating a new variable called j, which is starting from I minus one. So I will compare j variable with the key. The key is 12. So as value in the j variable is greater than key, I'm gonna be shifting j to j plus 1. So when I shift j to j plus 1, after I shift j to j plus 1, I'm gonna be decrementing j. So now j is j minus 1 and I have shifted 53 to j plus 1, j position to j plus 1. Now we have 53 and 53. Now, since we can't do comparison of j with key, right, because j is minus one, right? We don't have any minus one positions in array, so we're gonna be stopping here, and then we're gonna be replacing the j minus one, j plus one position. So when we are in the j's position, it means that the j plus one position element is already been shifted to j plus 2. So we're gonna be assigning our key value to the j plus 1 position. So here we're gonna be assigning 12 to this j plus 1 position, which is j equal to 0. So this is how it will be after first step. We have 12, 53, 35, 21, 59, 15. So after we are done, we're gonna be going to the next element. So the next element here is we this 35 value. So here again we're gonna be starting j from I minus 1. We're gonna be comparing j with the key, which is 35. So j is greater than key, so we're going to be shifting 53 to j plus 1 position. So now we have 12, 53, and 53. And I'm going to be decrementing j to the next left side. So when I'm in j is equal to 12, so I'm going to be comparing value at j, which is 12, with the key 35. So since the j is not greater than value at key, or value it appointed by I variable, we're gonna be stopping here, and we're gonna be assigning key to j plus 1. So since when we are in j position, it is fact that the j plus 1 variable is already being shifted to j plus 2. So j plus 1 is like duplicated. So we're gonna be assigning our key variable to j plus 1 position. So we're gonna be repeating this algorithm all the way such that we're gonna be reaching all the way to the end of this array. So for every iteration, we're gonna be shifting the values which are greater than the key. Key is nothing but the value pointed by variable I. To find a place for this key in the left side portion of the array or a list, and to place this key, which is nothing but the value pointed by the variable I, in the appropriate position in the sorted part of the array. So this is the logic for this. So here as well, the variable, the idea of variable I is to keep a note of position until which the array has been started. And then j starts from I minus 1, goes to all the way to first position to compare every value in the left side of I with the key, so that we can shift all the values which are greater than the key to right side to find appropriate place for the key. So this is how this algorithm works. Now we shall see the computer program for this algorithm. So now here we can see the computer program. This is written in Java language. So here I have an method called insertion sort, which takes an array. So here I have created a variable I, which starts from second element of the array, which is the index as 1, and all the way to the last element, which is like n minus 1. So here n is the length of this array. So for every I, I'm gonna be creating a new variable called j, and also I'm gonna be storing the value at I position of this array in a variable called key. So now I'll be starting a loop all the way from j as I minus 1 to j equal to 0. And then I'm going to be doing the comparison of array in the position j with the key. So if jth position value is greater than key, we're going to be shifting j to j plus 1. I'm going to be assigning value in j plus 1 as j. So and then I'm going to be decrementing the j. So this condition on this inner while loop is j greater than equals to 0 and value in array should be greater than the key. So we're gonna be continuing this inner loop such that we found a place where value in j is not greater than key. So at that point of time, we'll be assigning our key to j plus 1 position, and then we're gonna be incrementing the outer loop. So this is what we have discussed here. So for every I, we're going to be creating j minus 1. We're going to be comparing all the elements from j minus 1 to 0. So to shift the greater values which are greater than key to right side, so that we can find the appropriate place for key in the left side of portion. When we found the appropriate position, we will assign key to the that position which we found out. So this is how the computer program works for the second approach as well. Yeah, so here if we discuss the time complexity, so here we have two loops, right? One is for I and one is for j. So here if we see, if we assume the array is already sorted in ascending order, so we don't need to enter this loop at all, because since it is already sorted, the elements which is left to ith position will definitely be less than the value in the ith position, right? So definitely we won't enter this loop. We'll only enter this loop n times, as long as number of times as the size of array, and we're gonna be returning the array. So that is the best time complexity of this algorithm, which is big of n. And the we can say better, rather than saying big of n, we can say big omega of n. So in the worst case time complexity is when array is in reverse order, when array is in descending order. This algorithm, for every element we're gonna be looping all the way from j starting from I minus 1 to the first element. So basically, if we calculate it, the time complexity will be in the order of n square, n being the size of array. So that is the worst case time complexity. Since big O notation is all about the upper bound of the time complexity, right? So we can say that time complexity is of big O of n square, or else we can say time complexity is of big omega of n as well. So and the space complexity is constant. It is big of 1 because here we are not creating any data structure or any filling any data structures, right? So that's why time complexity is constant. So this time complexity is same even for first approach or second approach. So it is time complexity big of n square and space complexity is big of 1. Yeah, so in this video we have seen what is insertion sort, how to and we have seen an example on how insertion sort works, and then we have seen how two different logics, so basically both are almost similar, how to do the sorting, and then we have seen the computer program of these two algorithms also. Yeah, so this is for this video. See you in the next.